Welcome to my third preparation video in reinforced concrete design based on the Eurocode 2. I think now you have a clear idea about the concrete and steel. Today I am going to explain another important part in concrete. It is concrete shrinkage. What is concrete shrinkage? Let me explain first. The aspect of volume change in concrete is important to study as a design engineer. When concrete hardens, there is a reduction in volume. That shrinkage liable to cause crack in the concrete. That's we call the concrete shrinkage. Here you can see some cracks in concrete structure due to the shrinkage. Some examples of the shrinkage cracks. Mainly, there are three types of shrinkage: caused by the loss of water content in the mix, caused by the difference in temperature of the concrete, caused by the reduction of volume as concrete sets. Firstly, let me explain the concrete shrinkage caused by the water loss. How we can find the amount of water added to the concrete mixing in different purposes. Using the past records, referring the mix design, considering the trial test, we can find the amount required to mix the concrete. Let's check the process of concrete production. Firstly, batching plant produce the concrete. Slide showing the two processes for the explanation. Concrete used to make test tube and very next day demolding and cube submerged in water. The process we call the curing. Now you can understand in the entire process of the preparation of the test tube, very less amount of water loss. However, checking the actual phase, the significant amount of water loss due to the contact with the surfaces, pipelines, this will lead to the shrinkage of the concrete. In a summary, now you have idea, almost no water loss during the test phase. Significant water loss during the actual casting. Normally in practice, during the actual casting process, industry we are practicing to avoid this kind of water loss in the actual casting process. Wet all contact surfaces before concreting. Avoid casting in noon as much as possible. Cover the completed surfaces to prevent the evaporation. Now let's check the concrete shrinkage caused by the different temperature, second causing factor. You may know, water reacts with cement powder to form new stone-like material. The reaction is exothermic, meaning release a lot of heat in hydration process. So we call that process exothermic. It means the hydration process release a lot of heat. That causes the body of concrete to be and hot things expand. Concrete at the surface loses heat faster than the middle. The sinker faster. The brittle material with different expansion shrinking rates will get cracked. Right. Then we can discuss the precautions to minimize different temperature problems. Since the heat comes due to the hydration, reaction between the cement and water. You may know, experimentally proved that the most obvious way to cut down the portion of the cement by replacing the fly ash or ground blast furnace and slag can get the same strength of the concrete by replacing the amount of cement portion with the fly ash. The second precautions we can practice: avoid the rapid hardening finely ground cement if possible, because rapid hardening cement having high rate of the reaction. The third one is common sense, using the concrete with chilled water and using the coldest aggregate can minimize the temperature difference problem. Right. Move to the third cause of the shrinkage, concrete shrinkage caused by volume reduction. In the basic, the shrinkage begins to take place as soon as the concrete is mixed. We call the process the concrete setting. Due to the chemical reaction, you may know, new molecules occupy the lesser space than the individual cement and water. As it sets, it is volume shrinks. One beneficial effect is the shrinking concrete will grip on the steel bar type. The fifth one, when it is restrained from the shrinking. When it is restrained from the shrinking, important part, internal stress will be produced. Right? When it is restrained from the shrinking, internal stress will be produced in the concrete. But if the change in volume of the concrete is allowed to take place freely and without restraint, there will be no stress change within the concrete. But in here, we are going to discuss restraint of the shrinkage will cause tensile strains and the stresses. This stress can be calculated. Now we are going to check how to calculate the stresses. Okay. Now I am going to explain the calculation of stress induced by the shrinkage. Here is the illustration. First figure, you can see the original size of the structural member. When concrete set, you may know it shrinks. Shrinkage amount called epsilon Cs. Shrinkage amount called epsilon Cs. Our object here is to demarcate change of length due to shrinkage. Next, suppose the concrete is reinforced. There will be a still shrinkage but lesser amount because it still provides the partial restraint. Concrete will be stretched this amount, we called epsilon Ct. Epsilon Ct. Next one showing reinforced and restrained. The difference between these and the top one noted as the epsilon Sc. This is the amount of strain caused by on steel. This is the amount of strain caused on steel. Epsilon Cs, free shrinkage strain concrete. Epsilon Ct, effective tensile strain concrete. Epsilon Sc, compressive strain. This overall movement is reduced by the inclusion of reinforcement. By using the figure, now we can create the equation. Epsilon Cs is between epsilon Ct and epsilon Sc. Epsilon Cs equal to epsilon Ct plus epsilon Sc. Then convert strain into stress divided by modulus. You know, modulus of velocities, stress over strain. Then we can convert to the equation like this. Epsilon Cs equal to stress divided by the modulus of velocity plus stress divided by the modulus of velocity. Where you know FCT is the tensile stress in concrete. And concrete area is AC and the FSC means surface stress in steel. Steel area is AS. Equating the forces for steel and concrete, we can prepare the equation finally. From left side, FCG tensile stress of the concrete equal to AS divided by AC by FSC. FSC means compressive stress in steel. Right, then by substituting the equation, we derive from previous side FCT equal to AS divided by AC by FSC. So the equation, now we have new equation, epsilon CS equal to AS divided by AC by FSC total divided by ECM into stress divided by SC divided by ES. Modulus of velocities. Now we can rearrange the equation, then we can convert like second equation like this, and epsilon CS, we are going to divide equal to both sides stress by ES by the modulus of elasticity plus stress. Then alpha equal to ES divided by ECM. Where then we can convert to the equation epsilon CS equal to FSC divided by ES within bracket alpha AS divided by AC plus 1 close bracket. However, we are more interested in stress caused by the steel. We can prepare the equation finally. We can derive the equation moving the FSC to the left side. Now we have equation stress in reinforcement caused by shrinkage equal to, this is the equation we derived for the stress of steel reinforcement in restrained structure. Then we will look at some examples for your clarifications. By using the example number 1, now we calculation of shrinkage stresses in concrete that is being explained by the reinforcement quantity is between epsilon CT and epsilon SC. Plug the formula derived in epsilon CS equal to stress epsilon CT plus epsilon SC. Here they have given epsilon CS convert strain into stress divided by 10 power minus 6 modulus of shrinkage of the concrete stress or strain. They have given the modulus of elasticity. We can convert to the equation like this. Modulus of elasticity concrete as 215 kilonewton per millimeter square divided by the modulus of elasticity. We calculate the steel stress. After that, we can calculate the concrete stress. Where FCT is the tensile stress in concrete. The given information and the equation FSC area is the stress of the steel, and the FSC means compressive stress in steel. Epsilon CS steel area is 200 times 10 power minus 6. The forces for steel and concrete. ES is there. We can modulus compare the equations finally. Alpha is ES divided by ECM. FCT is equal to 200 divided by 50. AS divided by AC concrete reinforcement area. AS divided by AC is the reinforcement content. FSC. Putting all together, we get the result 35.3 Newton per millimeter square. By using the pressure, now we can, this is the stress of weight. This represents the amount epsilon steel in compress. For the design style of this day and epsilon is 500 Newton epsilon that is 7.06% plus the design SC. Then now convert moving to the next part. Relationship between the steel and concrete stress, modulus of elasticity, stress or strain, reinforcement content. We can convert to the equation like this. FSC, 35.3, what we have equal to early stress. Then we can calculate the modulus of elasticity plus stress tension in concrete divided by the modulus of 0.35 Newton per millimeter square tension in concrete. FCT is the tensile stress applicable when concrete is partially restrained by the reinforcement. The amount is actually negligible. And concrete area is AC, and the FSC means compressive stress by steel. Calculation of fully restrained area is stresses in concrete that is equating the forces by steel by the reinforcement only. For fully restrained, the stress in the concrete would be given by equation final derived in previous slide using the stress relationship. From left side, FCT equal to epsilon CT ECM. As we get the stress, tensile stress multiplied strain equal modulus of the concrete divided by A. Then they have given the modulus of elasticity FSC. Modulus of the steel FSC modulus of elasticity in concrete as 210 power minus 6 per millimeter square. Firstly, we calculate the steel stress. Then after that, we can calculate FCT. Now we can create the equation Newton per millimeter square. Epsilon C answer is according to the given information per millimeter epsilon CT and the equation and the partial stress scenario. Epsilon is stress of the fully restrained number CT depends on epsilon CS epsilon SC 200 times. 10 power minus 6
convert strain
second
into stress
example
divided by
modulus.
ES is their
Modulus of elasticity.
modulus of
Stress
elasticity.
law is strain.
Then
That
we
is
can
the
convert to the
calculation
ES
of
divided by
life span.
EM as we see equal to 200 divided by beta G quotation.
Stress fully restrained
AS divided by AC
stress
would be given as